At a distance of 1.5 million kilometers from the Earth right now, there is an object that looks like a magic crystal ball, the Delphic Oracle and the Eye of Sauron at the same time. With the only difference that it is absolutely real. The James Webb Space Telescope has successfully arrived at its destination. The Lagrange point is L2, and in the spring of 2022, he only had to calibrate his 18 mirrors. Teams of scientists drew up observation plans for years to come. Webb will consider how black holes swallow matter. We'll look through the previously impregnable walls of space dust. We'll see the birth of stars. But this is increasingly a routine. UEBA has much more daring tasks. In this video, you will learn how to find mysterious dark matter with the help of a new telescope. Will we see the reflection of other universes in the golden mirror of the Webb? And why did we actually launch the James Webb Super Telescope into space? Can James Webb's observations be used to calculate the exact rate of expansion of the universe? The Big Bang Theory tells us that the universe is constantly expanding. Stars and galaxies, which are not held together by the force of mutual gravity, move away from each other every second, and if we find out the exact speed of this expansion, then we will be able to calculate what awaits our Milky Way in the future, and vice versa. It is better to look into the past of the universe. The rate of expansion of the universe is called the Hubble constant and is measured in kilometers per second. For 1 megaparsec, astrophysicists have come up with 2 methods for its calculation, but here's the trouble. The results of different teams are catastrophically inconsistent. In the first, scientists take into account the rate of expansion of the cosmic microwave background. This is the thermal imprint of the young universe, approximately 380,000 years from birth. If you compare her with a 20-year-old girl, the microwave background, photos where she is only 5 hours old. As a result, using the microwave method, the first team calculated the rate of expansion of the universe at 67 kilometers per megaparsec per second. But the second team of scientists looks at how the luminosity of well-studied stars several million light-years away changes over time. This time we're looking at yesterday's pictures of the young universe. But wait, it has to be the same person, but the photo doesn't look like someone else's. Likewise, the rate of expansion of the universe calculated from the stars is 74 kilometers per megaparsec per second. And the 10% difference in the 2 results, it is impossible to explain. But can James Webb check which one is correct? Yes and no. The relict microwaves of the first team are 100 times longer than the waves that can be detected by a telescope. It's like using a microscope to try to examine not an ant, but a boa constrictor. The Webb mirror has a diameter of 6.5 meters, and will be able to collect enough light to notice the slightest change in the brightness of relatively nearby stars. That is, the second team will finally be able to name the super-accurate speed at which these objects are moving away. But what makes the universe expand anyway? We will never know the full answer to the unimportant part of the puzzle, the invisible and omnipresent substance with which the whole cosmos is enveloped. How can the observations of James Webb explain the phenomenon of dark matter? Astrophysicists have noticed that some galaxies move like this, as if they contain much more mass than can be seen, lacking an invisible mass called dark matter. According to modern estimates, it is 6 times more than all the stars, planets, and cosmic dust. The well-studied effect of gravitational lenses will help James Webb to find dark matter. This is when a massive body distorts light rays passing by with its gravitational field. Compared to the Hubble telescope, the UEB will be able to find such lenses a little further in space. In this way, scientists discover new clumps of dark matter and calculate their mass. So we will get closer to understanding what kind of substance it is and what exactly it consists of. There are disputes about this. But maybe dark matter. These are objects well known to all space lovers. Yes, black holes, but not the ones you're used to. Primordial black holes could have formed less than a second after the Big Bang from regions of space with enormous density. And these massive monsters could remain undiscovered until today. These are like secret pockets, visible only from the inside of the clothes. Since such a hole did not form from a star, its mass can be equal to both dust and the galaxy. In the early 1970s, Stephen Hawking suggested that dark matter could consist of these same primordial black holes. However, even with its superstar, will find it difficult to find the primordial black hole on its own. In this task, he will need a powerful partner, like Dr. Strange in the latest Spider-Man. In the year 2034, space will launch the LISA gravitational wave detector. It will detect the smallest fluctuations in space caused by the movement of large masses, and James Webb will look where LISA points. However, Stephen Hawking is known for an even more extravagant theory than primordial black holes. And if our telescopes confirm it, then the revelation of Copernicus that the Earth is not the center of the universe will seem like a joke of a novice stand-up comedian. Will James Webb confirm the multiverse theory? In the year 2018, the attention of the scientific world was riveted by Stephen Hawking's last surviving article entitled "Smooth Exit from Eternal Inflation," co-authored with physicist Thomas Ertov. But this is not the kind of inflation that makes a gallon of gasoline more expensive, but cosmic inflation at the birth of the universe. A normal explosion is a uniform expansion in all directions, but soon after the Big Bang, the universe suddenly began to expand with acceleration. In a millionth of a second, it expanded darkly into the immeasurable space, into which we launch expensive telescopes like James Webb's and still fail to see its limits. The problem is that in the theory of eternal inflation proposed in the 80s, similar sudden expansions still occur in various regions of the universe, and as a result, an infinite number of universes appears. Oops. However, in their article, Hawking and his partner blow this theory to pieces. They prove that cosmic inflation cannot be eternal. And this makes her look like an ordinary one. After all, a gallon of gasoline cannot cost an infinity of dollars. As a result, it turns out that if other universes do exist, there are not so many of them at all, and the conditions in them are not so diverse. Roughly speaking, in parallel worlds you may have a different profession, but the nationality will be the same. But the most incredible thing is that scientists have figured out how to test Hawking's theory of multiverses. For this, a special detector must be placed on the spacecraft. It can find traces of other universes in the same microwave background left over from the Big Bang. But, as we have already said, these waves are 100 times longer than the waves that the Webb picks up. So here our favorite is powerless. However, you should not be upset. After all, we can discover the most incredible worlds not in mythical parallel universes, but right now, in our galaxy. Will James Webb be able to find signs of life on exoplanets? In 2022, the number of discovered exoplanets exceeded 5,000. And this counting more than 2,000 candidates. But what's the point if they're all dead? That is why scientists are frantically searching for inhabited worlds. The idea is this: if there are living organisms on the planet, they will definitely leave characteristic biomarkers in the atmosphere. They can primarily be molecules of water, ammonia, and methane. But the surest sign of life in our understanding is chlorophyll. This pigment colors plants green and ensures photosynthesis. Chlorophyll absorbs various types of light, and is clearly visible in the infrared range. If the Webb notices such an anomaly on an exoplanet, it means there are plants there that obtain energy through photosynthesis. And here is an excess of phosphine gas molecules. Will indicate the presence of bacteria that can live without oxygen. Recently, its traces were found in the atmosphere of Venus. But to clarify its origin, additional research is needed. One way or another, all these biomarkers on other planets cannot be seen even by the most powerful ground-based telescopes. They are hindered by the Earth's atmosphere. Detecting life with Hubble is also impossible. It works in that part of the infrared spectrum where biomarkers are invisible, but James Webb's infrared range is 10 times greater. And he will definitely see biomarkers on exoplanets if they are there. But a real jackpot for astronomers. This is to reveal a highly developed civilization that has its own special markers. We, extraterrestrials, could find an excess of carbon dioxide, carbon monoxide, ozone and lead in the Earth's atmosphere. It is believed that there are about 1 billion terrestrial planets in the Milky Way. So the probability of discovering even a primitive form of life is greater than ever. And this will be James Webb's most valuable gift to humanity. I wonder what astrophysicists will do when they find all the answers to the mysterious mysteries of space. Perhaps they will take a break from the exhausting study of the universe. They will turn on light music, adjust the Webb to the gentle infrared range, and lazily watch the passionate merger of galaxies through the clouds of dust. But don't think too much. This is also an important part of studying the universe.